All right, so in this first topic regarding how we use matrices to store data, I'm going to show you some of the questions that are actually in your worksheet from your honors packet. So if you don't have that right now, pause the video and pull it out. Some of what I go over here in our lesson, you won't have to do later on your own because we'll do it in class. So take a look at this little clip that I have that I've taken directly from your homework. It's just the picture of the triangle ABC, which is for exercises 1 through 11. And I want to talk about, first of all, how a matrix can be used to store the information that is seen visually in this graph. So if I look at a graph, I usually think about it in terms of what my eyes see. And my eyes see a triangle, which normally I think of in terms of 3 lines, or also 3 points, 3 vertices. That is a visual description. However, if I want to take that data and make it something that would be understandable for, say, a computer, something that I can store with very simple numbers, I might want to simplify it down from saying something kind of vague like it's a triangle to something more specific like what are the coordinates A, B, and C of this actual triangle. And we know here that A is 4, 2. B is 4, -2. Oops, I put that in the wrong spot. 4, -2. And then we have C, which is at -3, 0. I will put that right here so it's not too far in the corner. Okay, so that is the data that describes our triangle. And one of the common ways for storing that in a matrix is to make columns that represent each of the points. And then let the rows represent X and Y. So I'm going to erase that because we normally wouldn't, but I will leave A, B, and C. So for instance, A is 0.42, so I just write 4 for the X and 2 for the Y. Then for B, I would write 4 for the X and -2 for the Y, and -3 for the X for C, and 0 for the Y. And that's it. This is a very simple outline of information that I could pass on to anybody very easily, and they could, as long as I had told them how to interpret it. So I could say, this matrix represents the vertices of a shape. They could then take this matrix and create the shape for themselves. So that's the idea of storing information in a matrix. It's kind of blah. There's nothing very interesting. It's maybe more pretty to look at the picture, but data-wise, it's helpful to be able to store it in something like a matrix. Now, why, we might ask, why do we care? Well, this allows us to do some fun things that we call transformations. That's a geometry term, and if you haven't taken geometry before, do not worry. I'm going to define those terms for us right now. So to start off, we want to think about the term transformations. And transformations are basically just taking a shape and changing it in some way. So it's changing a shape. Or changing a figure, maybe I should say, to be a little bit more general. There are 3 different kinds of transformations that we're going to talk about here. The first is called a translation. A translation is just another word for like sliding something. So a translation would be like if I have a star here and then I slide it to another place. That would be a translation, a slide. So I don't change the shape, I just change where it's positioned. I move it in some way, up or down, left or right. Another transformation is a dilation. That means that it's either growing or shrinking. So it maintains the same general shape, but it either gets bigger or smaller proportionally. Another type of transformation is the reflection. I had to think there for a second. And we know what reflections are because we see it in a mirror every day. That just means that we take an image. So if I had the letter D, the reflection would be kind of flipped across. So that's a reflection. Will change the orientation of a figure, but it doesn't change the size. And then last but not least, we have a rotation, which just means that we turn something left or right. So let's say we had like the letter R for rotation. It doesn't change its orientation like the D does. It doesn't look backwards, but it would either be flipped over on its side to the right or to the left. It doesn't have to be a 90-degree rotation. It could be 37 degrees of rotation. It doesn't really matter. So those are our transformations. Just a quick cheat sheet to put in your notes. Translation is a slide, dilation is to grow or shrink, reflection, we flip it, and rotation, we turn. Actually, I guess I should put those down here. So flip and turn. Okay. We're going to end the first video just by looking at how to label a figure with a matrix, and then also defining what transformations are. But obviously we're kind of in the middle of thought here. The question is, what does a matrix have to do with transformations of a figure? And that's what we're going to talk about in the second video, but I just want to start with a fresh, clean screen for you, and we'll continue from there.